Alright, so special quadrilaterals. I've got 1, 2, 3, 4 in this particular realm here, okay? So, a rectangle. What is special about a rectangle? How can we describe it? So, a rectangle is an equilateral. An equilateral parallelogram.
No, not equilateral.
I mean, sorry, equiangular. Thank you. Equiangular parallelogram.
What does equiangular mean again?
Oh, equal angular.
An equiangular parallelogram.
It's also the rectangle is like the square is usually all.
So equiangular means that they're all equal. So if every single angle inside a parallelogram is equal, then they all have to be 90 degrees, right? That's an equiangular parallelogram. That's how we're going to describe the rectangle. Yep. So all of these right here are rhombi, which is the plural of rhombus.
Rhombus.
The plurus. All three of these represent the rhombus. The orientation. All right, so the rhombus is an equilateral parallelogram, not an equiangular parallelogram. So each of those pictures represent a rhombus. Don't get confused about the orientation of the picture of the rhombus. Each one of those represents a rhombus. And yes, even that third one that looks like a square represents a rhombus, okay? Because it has to have equal sides. And we can draw multiple pictures that has 4 equal sides. They don't necessarily have to look like a diamond every single time. So don't get confused about that. So if we have an equilateral parallelogram, we're talking about a rhombus. For this one, for the square then, the next one we have, it's both equiangular and equilateral. And you guys, do you remember the word for something that is both equiangular? And there you go. So that means it's regular, right? So a square is a regular parallelogram because it has both equal angles and equal sides. That's what that means. So regular parallelogram, you got it. Okay, yeah. All right, here's a kite. So here's the definition for us for a kite. A kite is a quadrilateral, meaning quadrilateral means it has how many sides, you guys? 4 sides with 2 pair of consecutive congruent sides. So here's what I mean by that. This right here, that is a pair of consecutive congruent sides. That's one pair. The other pair is here. And they are consecutive and they are congruent, meaning that they are next to each other, consecutive, and they're congruent. If you have 2 pairs of consecutive congruent sides, we call that a kite. Okay, so let's dress up the picture now with all of the 4 special properties of the rectangle. Opposite sides are parallel, so that means that this side and this side are parallel, and this side are parallel. Is that fair enough? Okay, then the second one, opposite sides are congruent. So that means that this side and this side are congruent. And that means that this side and this side are congruent. Opposite angles are congruent. Well, we know that because it's all equal angular. And then the diagonals bisect each other and are congruent. So if I draw in a diagonal, I would draw in this diagonal there and that diagonal there. They bisect each other and are congruent. So bisect means that's equal to that, and that's equal to that, and they're all congruent. So those are the. Yep, that's what that says. They bisect each other and they are congruent. The rhombus has all the properties of being a parallelogram, but in addition it has these 2 special ones. So let's dress up the picture here. So the diagonals are perpendicular. So what does that mean? That means that if I drew a diagonal in here and I drew a diagonal in here, they would have to be met at right angles. That's what that means. And the diagonal bisects 2 angles. So what that means is that the 2 angles I'm talking about is this angle and that angle get bisected, and this angle get bisected. That's what that means. The diagonals bisect the 2 angles. All right, so the square has tons of properties. So let's dress that. Opposite sides are congruent, so I have that labeled. Opposite sides are parallel, so we can say that these are parallel. And this is parallel, and this is parallel to this. And we know opposite angles are congruent. And we know the diagonals are congruent, bisect each other, and bisect 2 angles and meet perpendicular. So if we draw the diagonals here of a square, We know that this is equal to that, which is equal to that, which is equal to that. We also know that they meet at right angles, and we also know that they cut this angle in half and this angle in half. Same with that angle, and same with this angle. So actually, these should all be this. Lots of properties for the square. Okay, here are the two special properties we need to know about the kite. The first one is that the diagonals are perpendicular. So aside from, all the regular stuff of the kite, saying that that and that and then this and this, aside from the regular stuff, the diagonals are guaranteed to be perpendicular, meaning that they would meet at right angles. But notice they're definitely not congruent, right? And they don't bisect each other in any way. But the other thing is that every kite has exactly one axis of symmetry. So I'm going to highlight where the axis of symmetry is. And can you see that this one right here is the axis of symmetry? Meaning that if you fold it in half, it would match up perfectly. But if you folded it in half the other way, it wouldn't. So a kite has exactly one axis of symmetry. So here's the setup for this random theory in the book. If you're given a right triangle, as the one that you see here on the board, and you take the midpoint of the hypotenuse. So the hypotenuse is the longest side. You take the midpoint of the hypotenuse. The midpoint of the hypotenuse of a right triangle is equal distance from all three vertices. So here's what I mean by that. It means that from this vertex to the midpoint, which we'll do in a different color so you guys can see. We'll do blue, okay? And then from this vertex to the midpoint, and then from this vertex to the midpoint, those are all congruent segments. It's equal distance from all three midpoints. So the theorem says this: the midpoint of the hypotenuse of the right triangle is equal distance from each vertex. That's what those blue lines indicate for you.